All right, so I have a lot of people here, which I think is not great for the grades for the upcoming exam here. But for those of you who showed up, there we go. We'll kind of work through some review questions today. If you have any questions, we can kind of start with those. Before I do that, I just wanted to kind of mention um, where we're kind of at in the class. So the things that are due um, by the end of the day today. So we have that Canvas discussion. We've got that quiz from yesterday is actually due before we would usually start class tomorrow. I would obviously suggest getting that done before you start the exam tomorrow. And then that second quiz is due by the end of the day today as well. So I will post an announcement that has the instructions for that exam. It'll get added in as what looks like a separate module right under here after class. I'll post it, but it won't be available until tomorrow at 9:30 a.m. You can then log on at any point in time from 9:30 to 3:30. You have an hour and 15 minutes to complete it, so you must start it by 2:15 p.m. to have the full time. Uh, I'll post the instructions as an announcement so that once you start, you don't have to kind of spend time reading through those. You can look at those in advance. You will have to use that lockdown browser. Um, and I will keep an eye on my email during that time frame. So if you have any technical issues or anything, please let me know immediately and I'll get you a quick response. Um, Other than that, I think that should take care. Oh, the other thing I was going to mention is after that exam, you'll see this fifth kind of module be released, and you'll have a top hat assignment. So that'll be due before we start class, excuse me, on Monday. So, make sure, I know it's July 4th weekend, but make sure you're kind of getting that done before we start class on Monday. Okay. Other than that, are there any questions for me before we kind of dive into material?
Are we gonna be able to see like the correct answers from the quiz due tonight before the test?
So, because it's due at the end of the day today, you won't be able to see the correct answers until after that due date passes. If you've submitted it, you can see what answer or what questions you got incorrect. And so, if you want to kind of rework those or have any questions on those, you can email me. Um, and I kind of mentioned this before, so you can see which ones you got right and wrong, and you should be able to kind of review the ones you got wrong. But you won't see the correct answers until after that due date passes. Any other questions? Okay. All right. So any content questions that people kind of want to see worked through here? If not, I've got kind of a set of questions that I think would be helpful. Um, and we can kind of work through those. Okay. All right. So we didn't do a lot of module 3 and 4 yesterday. It was kind of a lot from 1 and 2. I'll primarily kind of focus on 3 and 4 here today, but kind of relate that to some stuff for module 2 as well. So if I'm going back to thinking about GDP, when we calculated GDP initially, and this would be nominal GDP, we said that was going to be equal to consumption plus investment into capital plus government spending plus our exports minus our imports. Okay. So this was going to be, we said, our expenditure approach to calculating GDP. Now, when we have all of the amount that's being spent, that captures prices. So technically, we're thinking about this equation is how we would calculate nominal GDP. Okay. So, excuse me. So if I instead gave you something like this, so let's say the values I gave you to kind of keep this nice and easy. So let's do consumption was 2,000, investment was 1,000. Let's say government spending was also 1,000. Creative destruction. So in connection to what? I don't think we really talked about that in class. So
The textbook just talked about it a little bit, and I just was wondering if it was relevant. It was just confusing from the textbook. That's all.
no, I wouldn't. We if we don't cover it kind of in the slides, there's some stuff in the text that we don't go through, then I wouldn't worry about that.
All right, thank you.
Yeah. So what did I have? I left off here. So exports were 100. Um, and then I have my imports were 250. So if I make this calculation, I've got what? 4,500. So I've got 4,250. Now, if I also gave you at the same time the additional components, so we've got wages, rent, interest paid on capital, profits, depreciation, and business taxes. Right. So when we're using all of these, if we add these up, that is what we said was the income approach. So these two values, because we have a circular nature to our economy, should produce the same value. So let's say I told you that rent was 500, interest payments and capital are 1,000, profits are 500, depreciation is 300, and business taxes are 200. But I don't give you what wages are, right? So this is just a different way for us to calculate nominal GDP using the income instead of the expenditure approach. Because there's this circular nature to our economy, they should both produce the same value. So if in this question I asked you what are wages, you would calculate GDP using the expenditure approach. You know that that should be equal to the GDP using the income approach. So if I add these up, I get what? 2,000, so 2,500. Right? So at this point, right, if I wanted to solve for wages, I just kind of subtract both, subtract 200 and 2,500 from both sides. That should be equal to my wages. So I get what? 1,750 if I'm doing math in my head correct here. Okay. So I could give you any of these, like all of these components, but leave one out. And because you know that the income expenditure approach should produce the same value, you could solve for what's missing. Okay. Now, one thing I would point out here is to really, make sure you're not making a mistake. When we're looking at imports, we're subtracting that value. So notice I was subtracting 250 there. Okay. Any questions on that idea? Okay. So I'm going to try to keep the flow of things kind of, connect or have questions that are kind of related, follow each other. So let's say I have that income approach. We said the way that I'm calculating GDP is C plus I plus G plus exports minus my imports. Okay. So if I think about a question that says, let's assume that investments, right, increase by 500. Okay. Actually, let's do it. Let's do an opposite one. I think this will be better. Let's say investments decrease by 500, right? Or we lose 500 from investments. Well, that's going to cause my GDP to go down. So a question could be, in order for my new GDP or to be higher, what would have to happen to these other factors that kind of overcome this decrease in investment? So what would kind of cause my GDP to be higher even if I had this decrease in investments? So we can start to think about what I would need is an increase in these other components. So whether it's C, whether it's, well, we got I here, whether it's G or whether it's X, right? We would need all of them, or sorry, if we're choosing one of them, each one, if we had an increase in that category, could potentially overcome this decrease in investment. Now, what would have to be true is that they would have to increase by more than that decrease in investment. Right? So if I gave you potential numbers, let's say that consumption goes up by 600. Well, 600 increase is higher than a 500 decrease, so that would increase my GDP. If instead I gave you an example where I gave you the number and said, okay, what if exports go up by 400? Well, that's still raising my GDP, but it only increases it by 400 while investment decreased it by 500. So my new GDP would be lower. That's not that, that one's not going to cause my GDP to be higher than before. Okay. Any questions on that? And I could do kind of a similar thing with government spending. We would need an increase in any of these to be greater than 500. And we would need, anytime we had an increase that was less than 500, we still won't see GDP go up. Okay. Any questions over that idea before we keep moving? And you might see very similar questions to this on the exam. Okay. Now, a little bit trickier here. If I gave you an additional option, which is I only kind of looked at these three. Well, what about imports? Right? So what would actually have to happen to imports in order for me to get a higher GDP? Well, if I'm subtracting them, I actually need to subtract a smaller value. So I would need imports to decrease in order for them to increase my GDP. So if I'm thinking about there's this decrease in investment, what I actually need in order to overcome that is a reduction in imports. So let's say imports go down, right? If they go down by, let's say, 400, well, subtracting kind of 400 here, or sorry, subtracting an amount that's 400 less here would increase GDP by 400, but that investment decreased it by 500. I would still see my GDP go down. What I would need there is a reduction in imports that's something like 600, right? Something greater than that decrease in investment. Okay. And then if I ever told you in this example, let's say that imports go up, well, then you know for sure GDP is going to go down. It doesn't matter what this value is, because if I see an increase in imports, I'm subtracting a larger value. That's always going to cause my real GDP to go down as well. Or sorry, not my real, my nominal GDP here to go down as well. Okay. Any questions on that idea before we keep moving? Okay, so this next one, next question I can kind of think about here. I'm going to do it in Excel. We could kind of write this out by hand, which uh, I'll write some notes down and we'll kind of switch to them after the fact. But let's say I've got different time periods. So let's do, here's my 4 time periods. And I've got 2 goods and their corresponding prices. Okay. So if I choose the base year to be 2023 here, right? And I then ask you, what would um, what would be true about the price index, or if I'm looking for that price index um, of the year 2000, but using the base year of 2023. So that's kind of the setup for the problem. I'd have to give you some values. So I'm just going to give you the values of these 2 years. If you had a full table, these are the only 2 years that were, oh, I put 2023 here, sorry. 2000, now my math is, or I'm off a little bit. Let's do, what year did I skip? Here we go. So let's say I gave you the quantities here. So quantity, let's do price, quantity, and let's do price here. Okay. So I've got the price and quantity of the year 2000. That's what I want to find the CPI for. I have my base year. So let's say this is 140. So I've got 60. We'll do 240 and we'll do 90 here. Okay. So if I want to find the CPI of a certain year, or the price index, we said the price index is going to be equal to the cost of the market basket today divided by the cost of that market basket in the base year. Right? So how do I find these two? Or another way of thinking about this is, well, what is the cost today? That's my, being my real value. So you can kind of think about this as nominal over real. So, you know, we've got a very simple example here with two goods. But I wanted to find the kind of uh, cost today. I would take the quantity, right? I'm looking at the year 2000, so I would take the quantity currently times the current price. I would then add that up for both goods here, right? So if I'm kind of writing this out along the way, so we've got the cost today was equal to what? 100 times 40 plus 200 times 80, right? So if I hit enter here, I get that this is what, 20,000? Right? If I then want to find the cost of that same market basket, but in the base year, well, my base year here is 2003. So what I would do is I use the current quantities. So the quantities from the year 2000, but I multiply that by whatever the base year prices are. So most of the time we were kind of working in the opposite direction where my base year was an earlier time period, but you can always work backwards as well. So here I would take the current quantity of the year I'm trying to find the CPI for times the price of the base year. I would then do the same thing for the second good. All right, so if I wanted to find the cost in the base year of my market basket, we have what? 100 times 60 plus 200 times 90. If I hit enter here, I get 24,000. Okay. So I now have the cost of my market basket today, the cost of my market basket in the base year. If I wanted to find that CPI, right, it's essentially my nominal value over my real value. So I would take the cost of my market basket today divided by cost of my market in the base year, right? And if I do that, I'm going to come up with 0.83. Now, if I'm thinking about price indexes, what is the price index of the base year? Well, if I'm looking at the price index of the base year, when we were looking at, excuse me, the cost, we're taking price times quantity. Well, in the base year, the cost of the market basket today is the cost of the market basket in the base year, so it would be one. But when we're dealing with CPIs, we always take that ratio, but we multiply it by 100. So in the base year, we always have a price index or a consumer price index of 100, in which case, seeing a price index of like 0.8, hopefully we can say, oh, I made an error there. I forgot to multiply it by 100. Okay. So here, my price index is actually 83.33. That would be kind of the answer that I would put in for the question. Okay. Now, because that consumer price index in the old time period is less than in the base year. So why is that the case? Well, if this is a price index, that means that going from 2000 to 2003, my CPI goes from 83 to, well, the consumer price index of the base year is 100. My prices have actually increased. Sure enough, I can see here my prices went up. Now, that won't always necessarily have to be the case because I could see the price of one good go down But if I'm buying a significant amount of the good that had that price increase, I could still see that that price or CPI is lower, um, even though I had one of the goods prices decrease, right? So what this is telling me is that on average, prices increased, right, from 2000 to the base year of 2003 because the CPI went from 83 to the CPI of the base year, which would always be 100. Um, so anytime we have a CPI that's less than 100, that means that prices are lower. Okay. Any questions on that idea before we keep moving here? Okay. Make sure, let me check the chat here. It doesn't automatically pop up for me. Okay. All right. So this is kind of the idea of nominal versus real values. All right. So we kind of had those in here. If I want to kind of completely write this out, my price index, we said was the cost of the market basket today over the base year times 100. So this was just a matter of plugging our values in. Okay. So the next thing we're going to think about is let's assume that I gave you, oh, what do I want to do here? So let me try the different marker here. There we go. If we're calculating real values, or in this case, I'll do kind of real GDP, we said that's going to be our nominal GDP divided by our GDP deflator. Okay. So when we're thinking about this GDP deflator, all right, we are thinking about essentially my nominal over my real value. Okay. Now, another way of thinking about this is kind of similar to the previous question. This is really like thinking about what was my change in prices, right? Because if prices go up, then my nominal value will go up. But if I'm kind of adjusting for those prices, I'm taking out those price increases. This is just telling me the changes in output. So let's assume, right, that we've got, what do I want to do here? I'll do first, let's assume that we have inflation. Okay. So if I have inflation, right, then when I adjust for inflation, right, I'm thinking about I want to control for those prices. What does that mean? Well, if I have inflation, the nominal value will always be greater than the real value. Okay. So the reason why is kind of another thing that we had was if I'm thinking about my real value, that's my nominal value times kind of this price index. So this is like the CPI um, of the older time period, just to kind of choose a number to kind of go along with this. I could do old minus new here if I wanted to. Um, so if I'm thinking about here, when will this real value be less than my nominal value? Well, it would have to be if this fraction is less, so not less than zero, sorry, less than one. Okay. What is the only way this fraction is less than one? If that denominator, or the CPI in my new time period, is greater than that CPI in my old time period. So if I have inflation, right, I know that prices have went up, so I know that this kind of ratio of prices is going to be less than one. Now, one thing I left out here is technically we have to then multiply this by 100. So, this is just I'm kind of thinking more about the directional changes here. So if we have inflation, excuse me, we know that what's going to have to be true is that that real value is going to be less than my nominal value because my nominal value will be getting multiplied by a fraction that's less than 1. Okay. If that's the case, if my real value is less than my nominal value, right, my GDP deflator was that nominal value over my real value times 100. So if my nominal value is larger, that GDP deflator is going to be higher, right? Which would mean that my real GDP, if nominal GDP stays the same, that GDP deflator going up would cause my real GDP to decrease, right? Or that real GDP will always be less than my nominal GDP. So there's kind of two different ways of thinking about it there. Okay. Now, if I had deflation, right, what would happen there? Well, the exact opposite would be true. If I had deflation, right, then my prices in the prior year were actually greater than my prices in the current year. So that GDP, so I think about my prices are actually higher here. That would imply my real value or my real GDP is greater than my nominal GDP, right? If that's the case, this fraction is less than 1, my GDP deflator is going to be going down. So if I'm dividing by a smaller value, that would actually cause my real GDP to go up. Okay. So deflation, this would be kind of the relationship of real versus nominal GDP. Inflation, this would be the relationship between real and nominal GDP. Okay. Excuse me. So to connect this to then growth rates, right? Let's think about a statement we could make about the nominal growth rate versus the real growth rate. So just to kind of reiterate the previous example, my real GDP is my nominal GDP divided by this GDP deflator and then multiplied by 100. Okay. So let's think about a scenario where I think this will help solidify this idea. You don't have to do it. You could have non-base years, but in the base year, what would I actually be comparing? Well, in the base year, once again, similar to the cost basket idea, I'm looking at the current prices, and in the base year, those prices are the same. So in my base year, this GDP deflator, which is the ratio of nominal to real, this is going to be equal to 1, or none of my black markers are working here. I grabbed the wrong one. There we go. This would imply that my real GDP is the exact same as my nominal GDP. So we'll think about kind of a scenario where we're starting out in our base year. If we had real and nominal GDP values, I'd have something like, let's just do 500 here. Okay. So this is kind of where things start out, right? So if I had an example where I have inflation, right? So if I've got inflation, and let's say I know that the nominal GDP goes up, okay? So I've got inflation and the nominal GDP is increasing. What's going to be true about my nominal growth rate versus my real growth rate? So I could think about if I'm looking at kind of the following year, if there is inflation, right? I have an increase in prices and an increase in output. So maybe nominal GDP goes up to 800. But once I adjust for those higher prices, we said if there is inflation, nominal was going to be greater than real. That caused my GDP deflator to go up, which took that nominal GDP value and actually decreased it in terms of real GDP. So even though I have a nominal increase here, well, I told you we could still have, right, that my real GDP goes up because nominal GDP is the combination of the increase in prices because of inflation and the fact that our economy is producing more, the increase in output. Real GDP is adjusted for prices, so this just reflects the changes in output. So you think about before we even go through the growth rates, if I have inflation, well, real output is captured by both of these, but in addition, nominal GDP is capturing also the increase in prices. So if I was then thinking about, okay, if I wanted growth rates and I wanted to compare the real growth rate to my nominal growth rate, well, what would that be? The way that we calculate a growth rate, it's very similar to inflation. So inflation rates, we took the new price minus the old price divided by the original price. Growth rates for GDP, we're going to be taking um, that new real GDP minus my old real GDP divided by wherever my real GDP started out as. And then we have a similar thing just for nominal over here. All right, we're using nominal GDP as opposed to real GDP. Well, because real GDP is always going to be smaller, right? Once we adjust for those increases in price, we're always going to see that that real GDP growth rate is less than the nominal GDP growth rate. We can kind of see that from these numbers because I kind of started out in the base here. Well, what would have to be true here? So if we kind of plug these numbers in, there would be my real growth rate. If I instead had my nominal growth rate, there I'm just looking at the, new and old nominal GDP. I'd have what? 800 minus 500 divided by 500. So notice those denominators are exactly the same, right? In the base year, my real and nominal GDP started out as the same value. However, if I'm just strictly concerned with output, I want to look at my real GDP growth rate. Well, if I've got the same denominator, GDP growth rate is less than my nominal GDP growth rate. Where did I put my thing? Any questions on that idea before we keep moving? Um, as a follow-up, what if I had deflation, right? Well, if I have deflation, right, then we could think about, we said prices are going down, which actually would mean that my real GDP is not, did I have it written up here? Um, oh, we had it in the previous example. So if I have instead prices going down, what's going to end up being true is that instead of my real GDP being less than my nominal GDP, we said that the real GDP would now be greater than, right? In that case, right, my GDP deflator is not greater than 100, it's actually less than 100 because nominal over real, real kind of takes out those prices. Nominal included them, but if prices are lower, my numerator would be smaller, which decreases my GDP deflator, which then causes real GDP to go up. Now real GDP is greater than my nominal GDP. So if that's the case, right, now when I'm thinking about kind of inputting these values, that same increase in nominal wage, the real, sorry, nominal wage, nominal GDP, the real GDP would have to actually not be 800. It's going to be something larger than that. In which case, now the difference in my real GDP growth rate is greater than the difference in my nominal GDP growth rate. So everything just gets flipped, right? So if I have inflation, my real GDP growth rate is going to be less than my nominal GDP growth rate. If I have deflation, the real GDP growth rate is going to be greater than the real nominal GDP growth rate. Now, one thing I left off of all of this, I was being a little bit lazy. So if I make this calculation, like just for example here, I think I get, well, if I'm looking at this right, 100, so 0.2. If I tell you on the exam, and I will indicate this in every problem, but generally when I'm asking you for inflation rates or I'm asking you for growth rates, I always want you to input those values for the exam as percentages. Once again, I add in like a thing in parentheses to remind you of this. So if I ever came up with a growth rate, like this is a separate question, but if I wanted to actually calculate the growth rate, instead of zero point 0.2, I would be multiplying that by, I'm converting a decimal to a percentage. I just multiply by 100. So here that real GDP growth rate was 20%. And I think if I do the same thing here, this is what, zero point 0.6 times 100, I get 60%. Okay. Excuse me. Any other questions on that before we keep moving here? Okay. Let me see. I've got my list here. I'm looking through the examples that we worked through and seeing if I want to go through anything else.
This is sort of just a like superficial thing, but for the first quiz, when it asked us to round to the second decimal, and
Hmm.
it sort of gave us the example of 5.2 rounded to the first decimal, I was just wondering, is there like a rule of thumb of like how many decimal points we should round to, or will it be indicated in the question on the test?
Yeah. So every single question, and this is going to be in the instructions I post. I think in that question in particular, I had the margin of error set so that it didn't matter if you rounded to the first or second. Every single question, I'll tell you either to round to the second decimal or round to the integer. I don't have any first decimal questions, so it's always either round to the second decimal or round to the nearest integer for your final answer.
Thanks.
Yep. Let me make sure before I kind of switch gears here, I didn't have anything else I wanted to talk about here. Well, where are we at on time? Okay, I think I'll do one more here. Um, just to kind of show you a kind of example if I had simultaneous changes. So if we're thinking about kind of inflation and adjusting nominal values for real values, instead of using this GDP deflator like we had for GDP, where we had multiple kind of goods and coins there, let's say I had the real value in my current time period, and this could be income, minimum wage, etc. That's going to be whatever my nominal value was in the current time period, multiplied by the CPI of my older time period over the CPI of my newer time period, excuse me, times 100 here. So we can kind of ignore this for a second because the point I want to make is that I could give you a question, and this could be, once again, GDP, wages, income. Let's say, what happens to real income or real minimum wages if I saw at the same time an increase? Actually, let me color code these. Actually, no, I'll keep this here. I got another thing I want to add in. So if I had kind of this increase in my nominal wage or my nominal income in the current time period, but I also had at the same time inflation. Okay. Well, this is going to cause real GDP or income or wages to go up. But if I have inflation, what's going to be true about the CPI in my older time period compared to the CPI in my newer time period? Well, the newer time period, if prices are going up, this has to be larger, in which case, so if this is going up, the entire fraction is going down, which means that if I have inflation, that would decrease my real income, real minimum wage, real GDP. And so anytime I have inflation coupled with increases in nominal value, I don't really know what's going to happen to my real income, real minimum wage, or real GDP. Okay. So if I have simultaneous changes, sometimes the answer can be indeterminate. Now, that won't always be the case. So let's instead think about if I had the same kind of example, but instead of inflation, I had deflation. Right? So with inflation, right, we said we know prices are going up. So our old CPI was less than our new CPI, making this fraction kind of less than one, or kind of decreasing that fraction, which decreased real minimum wage. If I have the opposite of that, deflation, well, then my old prices are actually greater than my new prices. Or I could think about deflation as pushing this CPI down, right? Well, if my denominator is smaller, the entire fraction is going up, that would actually cause an increase in my real income, minimum wage, GDP. So if I had increases in nominal income or nominal wages, I also had deflation. I know for sure that my real value is going to go up. If I have inflation with that increase in my nominal value, there the answer would be indeterminate. And I could have any other combination of those two things, right? I could think about nominal decreases coupled with inflation, nominal decreases coupled with, I forget what I said first, with inflation or deflation. Okay. Any questions on that idea? Okay. Um, so let's switch gears. Let me make sure. Yeah, let's switch gears a little bit here. And let's kind of combine those two things that we were just talking about. So I'm going to be thinking about the GDP deflator. I'm also going to go back to thinking about my calculation for nominal GDP. And then I think we'll move on to thinking about more of production from module 4. So let's assume that we had an example where we'll just use, I don't know what's going on with my black marker. So I've got nominal GDP, and let's say it starts out at 600. Okay. I then tell you that consumption increases by 100. Okay. Well, when we were making that calculation for GDP, it was C plus I plus G plus X minus M, right? So if consumption goes up, right, my new nominal GDP is going to be what? 700? Okay. So I now have my new nominal GDP. If the end, let's say I started this question out and said, once consumption increases, what will be my new real GDP per capita? Well, I can determine my new nominal GDP. The additional piece of information I would need to then calculate my real or my new real GDP. Well, we said real GDP is equal to nominal minus my deflator. So I'd have to give you the value of the GDP deflator. Let's say in this example, I told you it was 130. Okay. So I've got my GDP deflator. If I want to now calculate real GDP, I take that nominal GDP, I divide it my price deflator, and I get 5.38. But I made a mistake, right? Because when any time I'm using this GDP deflator to calculate my real GDP, we also have to multiply this fraction by 100. And, hopefully you can kind of catch yourself if you make this mistake. Because if I'm looking at my new nominal GDP, how does adjusting for prices take it all the way down to 5.3? That would be like the, extreme inflation, right? So it should be a value that's at least somewhat close, right, to that, new nominal. If nominal GDP is in the hundreds, your real GDP should still be somewhere in the hundreds. So what mistake did I make? I forgot to multiply it by 100. So if I do that, I've got what? 538. And I think if I kept this out to the kind of more decimals here, so I think this was like 4.6 or something like that. So I now have my new real GDP. So this is like an example where when you're looking at the quizzes, I might break some of these concepts down like piece by piece. So the added probably difficulty of the exam is going to be that some of the questions will combine these concepts, right? Um, so, just as a larger point before we finish this example, I didn't mention at the beginning of class, is time on if time wasn't an issue on the quizzes, that's not necessarily going to be the case for you on the exam because even though there's 25 questions and an hour and 15 minutes have same time per question as the quizzes, 20 over 6, 25 over 75. Um, the questions will be a little bit more difficult, right? So that's one of the components I can play around with to kind of uh, make a exam more difficult is to play around with time, right? I can write harder questions or I can kind of have more or less time. So here, even though you have the same time per question, I'm going to play around with the difficulty. So if you're kind of going through these practice problems or going through the quiz uh, answers or to the point earlier, just kind of trying to rework the ones you got wrong, think about how you could combine two questions into one, right? So, like there's 40 questions on the quiz one and two combined. And so I'm consolidating all of those concepts down into 25 questions. So some of those will get kind of combined. So I want to make that point before we kind of continued. It popped into my head. I forgot to say it earlier. So I now have my new real GDP. What I kind of started this out was saying I could ask you all the way to the end point of what is the new GDP per capita, in which case I would have to give you an additional piece of information, which is what is the population. So if I've got real GDP kind of per capita, I'm essentially just dividing that by the population. So 538.46 divided by 40 is what, approximately 13.46. Okay. Sorry, my 1 and 3 kind of ran together there. Okay. So kind of combining multiple things into one. An increase in consumption will increase nominal GDP. I can then convert nominal GDP to real GDP by using that price deflator. I can then convert real GDP into real GDP per capita by dividing by population. Okay. Any questions on that? I'll add one thing in here as well. Another concept you could see pop up on the exam. So let's say I was looking at my real GDP per capita, and let's say I've got my real GDP, and let's just assume that it's the same in both of these time periods. Okay. I'll maybe go through an example here in a second. Well, yeah, we'll see. So I want to we'll see if there's questions. So we start out with the same real GDPs. Let's just assume that. But I told you that the population in 2025 is greater than it was before. So I have increases in population. Well, if I'm looking at real GDP per capita, right? If these numerators are the same and I'm dividing by the population from each time period, if I know that the population is greater in 2025, that means my denominator is larger relative to the earlier time period. If my denominator is larger, this decreases this fraction, which would mean that my real GDP per capita actually went down. Okay. Any questions on that idea? Well, what if I combined this, right, with I told you the population was greater, and I still want to know what's true about the GDP per capita of these two. But I told you combine this, there's a simultaneously, if this is the relationship between prices, assume that in 2025, we saw that consumption increase. When we see that consumption increase, what would be true is that our nominal GDP goes up. So remember, real GDP, right, was equal to our nominal GDP. And we could kind of think about this times the CPI ratio or divided by our deflator. It doesn't matter because if nominal GDP goes up, that means real GDP would also go up. So if we had these things happen simultaneously, then if real GDP in the newer time period is higher because of this increase in the nominal GDP, coupled with the fact that the population is greater in that year, these two things are working in opposite directions, right? The increase in the numerator caused my GDP per capita to go up. Higher denominator from a higher population cost to go down. My answer would be here, what happens to real GDP per capita? I can't determine. Now, I could have an example once again. Let's say nominal GDP went up, but I also had the population being lower. Then I would have both of those changes pushing real GDP per capita in the same direction, in which case I would know what happens to real GDP per capita with certainty. Okay. Other questions on that one? Okay. 5 minutes. So switching gears a little bit here. Let's say I've got a production function equation and I want to calculate my real GDP. So in the slides and stuff, this was kind of written as Y, or it represents output. But what measures output was our real GDP, right? We're getting rid of prices. Okay. So here I can think about, let's say I had a production function where I've got my total factor productivity A. I'm multiplying that by the amount of physical capital I have to the 0.2 power, and then multiplying that by the amount of labor I have to the 0.8 power. So if I give you a production function like this, I would typically also add in there, we've assumed human capital is normalized to 1, or we're not including human capital here. We could, but in this example, I'm not. Right? And I'll kind of add that in as we work through some other examples here. So if this is what I'm starting out with, let's say that my total factor productivity, or A, starts out at 20. Let's say the amount of capital, or K, starts out at 200. And just to kind of make this a little bit easier, so we'll do labor, or L. Let's say this is 300. Okay. If I then tell you that there's an increase in labor, right, and that it goes from 300 to 400, right, what would be my growth rate? So a standalone question, I could just ask you what's my real GDP if this was true. And in that case, it's just a matter of plugging in those values into your calculator. But if I made it a little bit trickier where I do, there's an increase in labor and then ask you what's the growth rate. So as a reminder, what is our growth rate? Our growth rate would be equal to whatever our new real GDP is minus, new, whatever our old real GDP was, and then divided by wherever our GDP started out or whatever it was in that older time period. So here I'll kind of write this out and then use Excel to be my calculator. But how do I calculate these values? Well, initially, right, my real GDP here was total factor productivity times the amount of capital to the 0.2 times the amount of labor to the 0.8. Okay. So I'm going to do the calculation here. I'm going to enter this into my calculator. So 20 times 200 to the 0.2 times 300 to the 0.8. Right? So yeah, so we get what? 5532.65. After that increase in labor, what is my kind of new real GDP, or my new output? Well, total factor productivity is the same. Capital has remained unchanged, but I now have this higher amount of labor. So if I do that math, get this entered into my calculator here, I get 6,964.4 approximately. So now it's just a matter of plugging these values in, right? Once I calculate using that production function, plugging them into my growth rate equation. Now, So I've got what? 6,964, and I'll kind of just drop off the decimals just for the sake of kind of writing this out here a little bit quicker. So if I do this calculation, I get what? 0.2587. So this is going to be now, oops. Now that's fine, right? But typically when we talk about growth rates, we're talking about them as a percent. So if I asked you, in this a question like this, I would tell you in the problem, enter your answer as a percent, and then give you an example of what that looks like. So here, if I want to convert this to a percentage, all I do is multiply that by 100, and my growth rate would be 25.87%. So using that production function and coupling it with the idea of how do I calculate a growth rate, that would be a question that you definitely, wink, wink, could see on the exam. Okay. Any questions on that before we keep moving here? Okay. So another type of question that could be related here is, let's say I have that production function. So I'm calculating real GDP, I'm taking total factor productivity, and let's do a different example here. So let's do K to the 0.5. And now let's include kind of human capital into our equation, and we'll do this to the 0.4. Okay. So if that's kind of my setup, and here's the following question that I have. Okay. Let's assume that the amount of depreciation is greater than the amount of investments we're making into capital. Okay. If that's the case, then we said, how do we determine what new capital is? It's whatever my capital starts out as, plus the investments I made, minus the amount of depreciation those physical assets had. So if depreciation is larger, this value is going to be less than zero. I know that my amount of capital is actually going down. So a decrease in capital is going to cause a decrease in my real GDP. Now, if I added into this question, right, maybe that's the first part, and then I say, okay, assume that at the same time, my labor outflows are less than my labor inflows. Right? So we said, how do I determine what my new labor is? It's wherever labor started out at, plus the inflows of labor, right? How many people are newly employed, minus my outflows. How many people did I kind of lose from my employee? How many are unemployed? How many left the country? And so if outflows are less than inflows, this value would be positive. My labor is increasing, in which case I have kind of competing effects. I couldn't say what's going to happen to real GDP. Now, once again, I'm showing you a lot of these as the answer is indeterminate. I would not assume that on the exam. I could just kind of flip this, right? So if I had changed this one instead to be like this, then the arrows are working in the same direction. I could definitely say that real GDP is going to decrease, or kind of the reverse, right? So once again, this is kind of linking. We've got changes in both factors of production. That's a concept. But we also have this concept of how are those factors changing. For capital, it's the relationship between investment and depreciation. For labor, it's the relationship of inflows to outflows. Okay. Any questions on that before we keep moving here? So in a question like this, you might think, okay, if they're working in opposite directions, right? You might look at this. I've got a question in the last section, like, yeah, but isn't the capital decrease larger? Well, not necessarily. I didn't give you enough information to know that, because in order to be able to make that comparison, we had to be comparing the same percentage change in both factors of production. I have no idea what the percent changes are here. Could have been that capital fell by 6, labor went up by 8%, or kind of vice versa. I just know the directional changes in a problem like this. So if instead I gave you a question where I did something like using that same production function, let's assume that capital goes up by 10%, right? So this is kind of the changes in K or my physical capital, right? If at the same time I had a decrease in my human capital of 10%, what's going to happen to my real GDP? Right? Well, we said what determines which of these is going to have a larger impact on real GDP is going to be the relationship of that exponent. So whichever factor has a higher exponent, it's also going to have a higher impact on my real GDP. So in this example, our exponent on physical capital was 0.5. Our exponent on human capital, so I can compare capital and labor, I can also compare capital to human capital. Sorry, physical capital to human capital. So if my exponent on human capital is 0.4, well, which of these 10% changes are going to have a larger impact, whatever is being raised to a larger power? So I know the same 10% increase in capital is going to cause my real GDP to go up by an amount that's larger than this decrease in human capital cost, in which case I know my real GDP is going to be larger. Okay. Any questions on that idea? Okay. Is there anything else I want to say here? So what if I had the same 10% change in total factor productivity? Right. So if I had a different scenario where I had simultaneous changes, or I was just comparing, the same 10% change to all these things, we said that total factor productivity, if it ever has the same percentage change as any of the factors of production, capital, labor, or human capital, the impact of that same percentage increase in total factor productivity will always be larger than the same percent increase in those factors of production. Why? Well, we said we can think about anything to the first power is itself. So A is always being raised to the first power. Every production function that we look at or that we have, the exponents here are less than 1. So it's always going to be the case that total factor productivity has the higher exponent. So this relationship we were talking about down here, it's what has the larger impact on real GDP, always the factor that kind of has a larger exponent. Total factor productivity will always have a larger exponent than physical, human capital, or labor. Okay. So I just want to kind of reiterate that concept when we're thinking about increases in total factor productivity, or what was representing that was A. Okay. Just as kind of a follow-up with this as well, I think I might have mentioned this yesterday, but if I see the same percent increase in human capital and labor, which of those is going to have a larger impact? Well, if they're both being raised at the same power, they have equal impacts. Right? So kind of mentioning that might be something that you see pop up as like a potential answer on a question, like if which of the following are true. Sorry. So let me look at my list. I think we've gotten through most of it. I know there's one more thing I want to go through. Is there any other topic or kind of type of question that anybody had a question on before I kind of do the last problem that I had on my list?
I was just wondering if we'd ever have to like analyze the what is it? Those graphs that we got. What are they called? like the per worker function or whatever.
Oh, yeah. Yes, that I very well could ask you a question like that. So when we had these per worker production functions, we said typically we think about this as capital, but we could do the same thing for investments into labor, right? So we said if we're thinking about, so if this was my production function, we said that as we invest more into capital and as we invest more into labor, yes, our real GDP is going up, but it's increasing at a decreasing rate, right? So if I gave you a question like which of the following are true, it would be that increases in capital or labor, yes, they're increasing real GDP. Real GDP will be higher than before, but it's increasing it at a decreasing rate, right? The slope is getting flatter. Now, what might be a little trickier is let's think about some statements that could be made if I had total factor productivity or A increase. Well, that's going to at every point kind of increase my total production. So there's two ways I could think about this, or there's two statements I could be asked to analyze. The first that would be true is if I have the same investment into capital, right? Or I could also say this if I had the same investment into labor. What will be true about my GDP after this total factor productivity increase? Well, at the same level of capital, right? With that total factor productivity increase, I get a higher real GDP. I mean, that's basically what we did numerically. Oh, where was that? Here, right? Increases or labor or increases in capital, right? If I continued, oh, sorry, we didn't go through an example like this. But with this function, if I invest the same amount into capital and labor, if total factor productivity goes up, even if those factors remain the same, my real GDP is now higher. Now, another statement I could make, it's just kind of looking at the reverse axis here, is if I have a total factor productivity increase, what's the other statement I can make? Well, in order to achieve kind of the same GDP or real GDP, then before I required this amount of capital or this amount of labor, we could kind of do either one. With a total factor productivity increase, to get the same real GDP, I actually need less capital than before. So to get to the same level of GDP from a total factor productivity increased, I can invest less into capital to get that same GDP. Once again, you can kind of think about this with a function. If total factor productivity goes up, if this remains the same, well, then I could actually decrease the amount of capital investment I'm making. And right, this wouldn't change, right? If these equally offset each other. That's essentially what this is saying. If I want the same real GDP after that total factor productivity increase, I require less capital or less investments in the capital than I did before to achieve that same real GDP, which right is a good thing, right? And then I could also write this for labor. The same would apply. It's just a different factor of production there. Okay. Is that where you were kind of referring to?
Yes, I was just like, we didn't get many practice questions on it, so I was wondering if it was going to show up on the exam.
Yeah, I would expect something in statements kind of similar to what I just made. Okay. Um, the other question that I definitely know that you might want to be able to do um, is the following, right? So I kind of rushed through this, but it leads us into kind of future topics. So I want to make sure I kind of go through it here. Sorry. So it was the relationship that we had between economic inequality and GDP growth rates. So this was called the Kunetz curve. I think I'm saying that right. And here was kind of our relationship for these, right? So as GDP growth increases, we kind of have this different relationship about how it's going to impact economic inequality. So one statement that we can always make, it doesn't matter if I'm at low levels of GDP growth or higher levels of GDP growth. What is always true about the economic inequality caused by any amount of growth greater than zero? It's always going to cause some economic inequality. So anytime I have GDP growth, just anything above zero, I always know that it's going to cause my it's always going to cause some positive amount of economic inequality. Okay. Now, the other types of statements I could make is let's assume I have relatively low GDP growth rates. So if I have relatively low GDP growth rates, then further increases in those growth rates will do what? Well, further increases in that growth rate is going to cause my economic inequality to go up. Right? But notice, as this goes up, what's happening to my slope? It's getting flatter and flatter. So from low levels of growth, if I increase my growth rate even more, it leads to higher economic inequality, but at a lower or at a decreasing rate, right? So like the same 1% increase in growth here is going to cause a larger change in economic inequality than that same 1% increase here. Now, on the flip side of this, I could think about, okay, what statements are going to be true when I'm looking at relatively higher growth rates? They're kind of over here. Well, if I'm at higher growth rates, if I increase my growth rates to be even higher, well, what's now happening to my economic inequality? Economic inequality starts to decrease. So kind of the exact opposite relationships between increases in growth rates at relatively low growth rates compared to relatively high growth rates. And then, yes, economic inequality is decreasing, but in fact, as I increase my GDP growth rate at these higher growth rates, not only is it decreasing, but it's decreasing at a higher or increasing rate, right? That slope is getting steeper and steeper. So I would kind of know these relationships between increases in growth rates at relatively low and at relatively higher starting growth rates, the impacts that they have on economic inequality. Are they increasing it or decreasing it? And then is it increasing at a lower or higher rate? At low levels, it's increasing at a lower rate. High levels, it's decreasing at a higher or increasing rate. But no matter where we're at in terms of growth, anytime we have any growth rate above zero, the economic inequality is always going to be above zero or positive. So we'll have some level of economic inequality if we have any growth. Okay. And then I could work in the opposite direction as well, just to kind of make the point before we end here. Let's say I was at higher levels of growth. If I see a decrease in growth, I'm kind of working backwards. Well, then my economic inequality would actually be increasing because I'm kind of moving back up that hill, so to speak. Okay. All right. So that kind of runs us out of time here today. So I'm going to stop the recording here.